So this question, we're given the sequence a sub n equals -1 to the n over 2n. Let's find some values. If n equals 1, wherever I see an n, replace it with a 1. So a sub 1 is -1 to the 1 now, divided by 2n, divided by 2 times 1, -1 over 2, so that we get a sub 1 is -1/2. Next one, I want n equals 2. So wherever I see an n, replace it with a 2. So a sub 2 equals -1 to the second over 2 times 2. -1 to the second is +1. 2 times 2 is 4. So a sub 2 is +1/4. N equals 3. We'll say a sub 3 is -1 to the third over 2 times 3. Now, what is -1 to the third? -1 times -1 times -1 returns a -1. 2 times 3 is 6. So a sub 3 is -1/6. Next, we go to n equals 4. N equals 4. A sub 4 is -1 to the fourth over 2 times 4. -1 to the fourth would become a +1 now, right? -1 times -1 times -1 times -1 would become +1. 2 times 4 is 8. So a sub 4 is +1, 8. Notice the signs are alternating, negative, positive, negative, positive. And that will continue when I go to n equals 5. A sub 5 is -1 to the fifth over 2 times 5. -1 to the fifth will be a -1. 2 times 5 will be 10. So a sub 5 is -1/10. Let's quickly check those on the graphing calculator, if we can. So I'm going to go onto the graphing calculator. Let's make sure we are in the correct mode. So the mode button is up here. I want to be in sequence mode. And if I'm in the sequence mode, you'll notice when I hit the y equals, you get a sequence editor. So the minimum value typically is 1. You could start somewhere else. You could start at 5 or something else, but we're going to want to start at 1 because we wanted a sub 1 as our first value. Now, what was my sequence? It was -1 to the n over 2n. And I'm going to use the same letters because, again, n is the letter that the graphing calculator likes. A lot of textbooks prefer k, so we'll go back and forth between n's and k's. So we want -1 to the n. So upstairs, parentheses upstairs, I want -1 to the n upstairs. This button will now be n. Okay. Once you're in sequence mode, that button becomes n. So -1 to the n here, divided by parentheses 2n. So that works. And I could go to my table, starting at 1, change in table is 1, that looks good. Second table will show us our numbers. And what do we get? -1/2, so -0.5, 0.25, which is a quarter, -0.1667, which is -1/6, 0.125, which is an eighth, -0.1, which is -1/10. Notice those are the same numbers that we had here. A sub 1, -1/2. A sub 2, a quarter, a sub 3, -1/6, a sub 4, an eighth, a sub 5, -1/10. But there's one other way, frankly, that I prefer on the graphing calculator, and that's to go to second stat. Second stat, ops, number 5 is sequence. Hit enter. And this is from when I put it in before, so I'll put it in again now. The numerator is -1 to the n. So I'm going to put it in like this just to make sure there's no issues with order of operations. -1 to the n divided by 2n, excuse me, 2n. So you'll notice the top is in parentheses, the bottom's in parentheses. My variable is n, which is here, right? So if I clear that for a minute, You'll see if I hit x t theta n, n comes. Starting at 1, fine. Ending at 5, 1. Ending at 5, correct. Stepping 1 each time, great. Paste. And this gives me the syntax to go directly to that seq command. And here's the answers, which if I change them to a fraction, there is my -1/2, a quarter, -1/6, an eighth, -1/10 that we wanted, that agree with what we had before. Now, what was the next thing that was asked? We're supposed to find the sum as k goes from 1 to 5 of those. So sum as k goes from 1 to 5 of a sub k. Would mean what? Would mean a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. So a sub 1 was -1/2 plus a sub 2 plus a quarter plus a sub 3 minus a sixth plus a sub 4 plus an eighth minus a sub 5 minus a tenth. So let's go to the calculator to do that. Make sure you see that's a 2, 1/2. So we'll quickly go to the calculator to do the computation and see what we get here. So -1/2, negative button is here, remember. -1/2 plus a quarter minus a sixth plus an eighth minus 1/10. And what do we get? That number, so about -0.392. Three decimal places is what I usually like. So we have that approximation, but I can also get this done directly on the calculator. So let's talk about that. So I go to math, and then I go to 0, which you'll notice is summation notation. And this time I think I'm going to go ahead and use the letter K. That's my preferred letter for these. So K is here. As K goes from 1 to 5, arrow at 1 to 5. And I want -1 to the n over 2n, but I've got to use my K letters instead. So I need a whole bunch of parentheses here for this to make sense. So that's the parentheses for the top. So -1 to the K and then I want to end the parentheses for the numerator of this thing, divided by 2n, which in my perspective will be 2k. You could have used n, I just prefer to use k. And I want you to be comfortable with both. And then that'll end the parentheses for the denominator. And we hope we get about -0.392. And sure enough, we do. And now what is our last question that we certainly could not add reasonably by hand? That is, the sum as k goes from 1 to 500 of a sub k. So sum as a goes from 1 to 500 of -1 to the k over 2k, because it was -1 to the n over 2n. So this is what we are going to feed into the graphing calculator. Sum as k goes from 1 to 500, -1 to the k over 2k. Is it somewhere around -0.392? Let's find out. Back to the calculator. And math, 0, which quicker to go up rather than down. Summation, this time we want k going from 1 to 500. So it's already in alpha mode, so go to k, goes from 1 to 500. Whoops. 1 to 500. And again, we have to just plug that thing in again. So the numerator button and then the -1 to the k parentheses. So yeah, it's a little hard to keep the order of operations straight. -1 to the k. That finishes the numerator, divided by doing the denominator 2n or 2k. That finishes the denominator. And then you can see this parentheses here is for just the summation notation. And what do we get? It's going to take a little while for this to compute. No surprising there. It's got to add up 500 numbers. Negative 0.346. So in the neighborhood of the negative 0.392 that we had, we just added the first 5. So it kind of gives us an idea that maybe this thing converges, and we will prove that in later classes.